Hey, this is Mr. Janes. In this video, we're going to be talking about triangle congruence and rigidity. To start with a warm-up, think about this. Engineers often build many structures using triangles. Give at least 3 examples of where you have seen triangles used. Hint, look at the pictures below. Number 2, why do you think triangles are so important in engineering? Okay, think about those for a second. Pause the video, think about them, maybe jot down a few ideas, unpause the video, and we'll talk about it quickly. Pause the video in 3, 2, 1. Alright, so engineers often use triangles in things like bridges, the Eiffel Tower, roller coasters. They're even used in the desks in this classroom and in the steel beams you maybe see on the side of this room. And why are triangles so important in engineering? Well, it's because they are rigid, which means that if the 3 sides are put together of a triangle, if some sort of stress is put upon them, they won't move, even though the angles aren't fixed. Here's what I mean by that. If you've got a triangle like this, okay, you've got a triangle, and you have maybe 3 steel beams like this, 3 very strong steel beams, but you just kind of bolt them together and the angles aren't fixed. The angles could bend. Even if you put pressure on the triangle, it's not going to move. On the other hand, if you've got something like a square, okay, with 4 very strong beams, you just bolt them together, you put some pressure on that, right, it might not stay as a square. The angles might bend and form a shape like this, like a rhombus, right, when you put that pressure on it. That's why triangles are so good in engineering. And oftentimes we want triangles just like this, triangles that are rigid and do not move. However, sometimes we want triangles that are not congruent, are not rigid, and can move. So what I'm going to ask you to do at this point is watch this video right here about the Petronas Towers in Kuala Lumpur. These 2 very tall skyscrapers have a bridge between them, this bridge right here. And this bridge is held up by these two beams. And the way that bridge interacts with the buildings is very different. Those triangles actually are not rigid. So what I'm going to do is have you watch this video. The link is right here. Pause now, go watch the video, and come back when you're done, and we'll talk about these 3 questions. So pause the video and watch the Petronas Towers different video with this link in 3, 2, 1. Alright, hopefully you've watched that video now. Let's talk about some of these things. In the video, they told you that this bridge right here is actually not attached to either building. It's actually can float and go in and out of those 2 buildings. So that bridge is actually not a fixed length. The length of that bridge can change. It can go in and out of the buildings. On the other hand, this distance right here and this distance right here are the same length, and they won't change. It's not like the building's getting bigger or smaller. And this length right here and this length right here are the same, right? So we've got 1 side that's the same, 2 sides that are the same, but only those 2 sides are the same. The other sides, this one right here, is allowed to change. And the angles are also allowed to hinge, like this angle right here might not be the same as this angle right here. Those are hinges. So the question is, just because you have 2 sides that are the same on those 2 triangles, does that mean those 2 triangles are congruent and they form rigid, unmoving triangles? And the answer is no. Those triangles with just 2 sides congruent can still move, right? What we're going to be doing in this lesson is talking about other qualities. Like, what if I have 2 triangles where all 3 sides are congruent? Does that make the triangles rigid? What if I've got triangles where 3 angles are congruent, but the sides don't matter? Does that make the triangles congruent and rigid? What about 1 side and 2 angles? Does that make the triangles rigid and congruent? That's what we're going to be doing here. Now what we're going to be doing is taking pieces of pasta and different angles, and we're going to try and make 2 different triangles that have the same conditions. For example, we're going to make 2 triangles where 2 sides are congruent and the 3rd side, the other 3 angles don't matter, and see if that forces the 2 triangles to be congruent. To be able to talk about these a little more easily, we're going to write all these out in a shorthand. Okay? When I talk about 2 sides having to be the same, I'm going to write that as SS for side. 3 sides, I'll write that as SSS. 2 angles will be AA for angle, and 3 angles will be angle. For 1 side and 1 angle, I'll write side, angle. What about 1 side and 2 angles? Well, there's 2 ways to look at this. We could look at this as maybe a side in between 2 congruent angles, or we could look at this as 2 angles and then the side on the end. That's the same. For for two sides and one angle, it could be side, angle, side with the angle in the middle, or it could be side, side, angle with the angle on the end. And we're not going to talk about 8 in this video, but we may come back to it later. So, as promised, we're going to take a second now and break these down and try and make two different triangles that have all of these different conditions and see whether those two triangles have to be congruent. If they have to be congruent, that means it's a rigid triangle and that this condition is good for making rigid triangles. So, let's skip over to using that pasta. We're going to start by taking a look at number 1. Number 1, and the condition number 1 on our note sheet is that the two sides are the same, and we call that side, side, or SS. So I'll put that right up here just so we can see it. So side, side is what we're testing right now. So what I'm going to do is take these two sides, which are congruent, and these two sides, which are congruent, and try to make two different triangles out of them, and see if those triangles have to be the same. So let's see, we got these two are the same, and those two are the same. So my first triangle, maybe I'll just take it and go like this, right? And let me just finish off my triangle with an extra little piece of pasta here, okay? And so, with these two sides, I made this triangle. I could do it again over here, and this time I could make the angle much, much wider, and then finish off with some pasta, and actually put it together like this. And with these two same sides, as the two sides over here, I made this triangle. Now, these triangles are definitely not congruent, which means that just because I start with the same two sides, doesn't mean that I will make the same triangles. Which means that side, side is not a condition for these two triangles to be congruent, is not a condition for these two triangles to be rigid and stable. So, number 1, two sides are congruent. Let's draw a quick picture here. This is kind of my first little pasta triangle, and my second pasta triangle is much bigger, right? And these are definitely not congruent, so these are not congruent / rigid. Alright, DG. Alright, there we go. Not congruent and not rigid. Let's skip down to something like number 7 for side, angle, side. Two sides and one angle in between it. Back to the pasta. Alright, and here I am with side, angle, side. Now, both these two triangles that I've started to make, I've got the same length first side, an angle in between that's the same, 30 degrees, and a last side that's also the same. So, side is the first side, angle, the angle in the middle, and the last side at the bottom. If you look at these two triangles, there's really not much you can change about them, right? There's nothing I can bend or flex or change about these. The really only thing I can do is just finish the triangles off by adding a little bit of pasta to that last side. Okay? And so since there's really nothing we can do to change these, okay, those two triangles will be congruent. If you've got a side that's the same, an angle that's the same, and one last side that's the same, with the angle in the middle, those two triangles will be congruent. They will be stable and rigid. Back to our note sheet. Okay, so we've got one triangle with a side, an angle, and a side, and another triangle with the same exact side, angle, and side. That means that they are congruent. So yes, congruent. Oop, congruent, exclamation point. Let's go back to the towers from the beginning. Now, if these two towers had two sides that were the same, such as this side and this side, and another pair of sides that are the same, such as this side and this side, now those two triangles would have side-side congruence. And we just learned that side-side isn't really a kind of congruence. The triangles would not be rigid, they could still flex, and this bridge would be allowed to move in and out of the two buildings, and everything would be okay. But let's say someone came along and had a welder and a big piece of metal, and they welded this angle right here. They put that in right there. Now that angle is the same on both of those two triangles. Well, now we don't have side-side, we have side-angle-side, like we just saw. And we learned that side-angle-side is rigid, is congruent. What would happen? Well, the buildings, the buildings would sway apart, but because these two triangles are congruent, are rigid by side-angle-side, the bridge would rip right out of the buildings, right? The bridge would rip right out of the buildings and the whole thing would collapse. So that's why it's important to know that side-side is not rigid, allowed to move. Side-angle-side is rigid, can't move, and that bridge would rip right out of the buildings. Let's go back and look at a few more examples. Particularly, let's look at side-side angle, where the angle is not between the two sides. Back to the pasta. Okay, so here we've got two triangles with the same side, another same side, and the same angle here, the same 30-degree angle, but it's not included in between those two sides. We call that side-side angle because the angle is kind of on the end. Now it looks pretty much like if I just finish these triangles off, they're going to be congruent, right? Just like that. And if I took another piece of pasta, they're going to be congruent, just like this. But looks can be deceiving because there's actually a little trick you can do here, right? What if I took this side, push this away for a second, took this side, and just simply hinged it in like this, till it lined up like that, and then look at that. I've still got the same side, still got the same other side, still got the same 30-degree angle, but these two triangles are definitely not congruent, right? So let me just demonstrate one more time. We can go from here to here without changing any of the original two sides or the original angle, which means that side-side angle is not rigid, right? I can make two different triangles with the same two sides and the same angle in that order. So if you've got a triangle like we just had, right, you've got the same angle here, same side and this side there, and then you try to make another triangle with those qualities, you actually might not get the same triangle, right? You could have one where this piece kind of is bent in like that, right? You can kind of see that from there. So this triangle with side angle and this triangle with side angle, they still have the same sides, and angles, but they're not congruent. Not congruent. So if you found a triangle with the same side angle in that order, not necessarily rigid, not necessarily congruent. Now, the rest of our classmates in other classes have gone on and taken a look at all of these other versions. I have pictures to show you of what they found. Let's take a look at them. All right, so we found in another class that angle, and having three angles congruent, neither of them work for congruence. If you look at these triangles they made, they have the same two angles, and these two have the same three angles, but they end up being different sizes. They end up being similar, right, bigger or smaller, but not congruent at all. Let's just jot that down in our notes. So having two angles, one there and one there, and having two angles, one there and one there, congruent, does not give you congruence. And having three angles, just basically the same thing, right? Just because you have the three angles the same, right? 1, 1, 2, 1, 2, 3, does not mean, X, that they are congruent. Let's check back with some other classmates. We found that having two sides congruent doesn't really do much for us. We already knew that, right? If you've got only two sides that are the same, not congruent. However, if you have got three sides that are the same, SSS, like these two found, they made the same exact triangle with the same three sides. That works with number 2, right? If you've got two triangles, so one there, that have the same congruent three sides, then the whole entire triangle is congruent. Yes, they're congruent. Okay? What about if you've got two angles in one side? Well, if you've got a side in between the two angles, just like Miss Pierce has here, that works. Same thing actually if you've got a side that's not between the two angles. Let's go back to our notes. So again, we've got two triangles, same angle, the same side in between, the same angle on the end. Okay, those triangles are congruent. Yes. If we've got two triangles that have the same angle here, same angle there, and the side is not between the two angles, they're actually still congruent. Yes, so both angle side and angle side both work. And here we've got the last two that we've actually already done, but here's two students with side angle side, and they did that, and they found, just like we did, that hey, the two triangles have to be congruent. But here's Dr. Carlson. He's got two sides with the angle not between them, and he's got a little picture. He's showing us that, yeah, that those two triangles are not congruent. You can kind of swing that last side in, just like we saw with the pasta earlier. And those two are already in our notes right here, SAS and SSA. Let's sum it up, come to a conclusion at the end. If two triangles have the following congruent parts, then the entire triangle, including all corresponding angles and sides, are congruent. So which ones worked for us? Which conditions gave us congruent, rigid triangles? So it turns out that side, angle, and angle, side, those conditions all work to give us congruent triangles. On the other hand, angle, and side, angle definitely do not give us congruence. And you might be confused with those later, so here's a way to remember it. The only two that don't work are angle, and side, angle. If you have trouble remembering that, just read it backwards and think about what you'll look like if you try and use it in a congruence proof.